Almond flour has a problem. It's dense, often greasy, and it rarely gives you that light, structured crumb. So a common suggestion is this: toast it first. The theory is simple: remove excess moisture, deepen flavor, improve structure. But here's the real question. If almond flour fails because of structure, will removing moisture actually fix that? Or will it make it worse? Today, I tested raw versus toasted almond flour side by side. Same recipe, same measurements, same bake. In the low-carb world, almond flour is everywhere. It replaces wheat in muffins, quick breads, pancakes, even cookies, right? For people avoiding traditional flour, it's not optional. It's foundational in low-carb baking, which means when almond flour produces dense, crumbly, or greased baked goods, that limitation affects nearly every low-carb recipe built on it. If toasting could fix its structural weaknesses, that would change a lot. But first, we need to define the real weaknesses we're trying to solve. Before we talk about toasting, we need to define the problem. When almond flour fails, what actually fails? Is it flavor? Is it moisture? Is it density? Or is it rise? Because if we don't define the problem correctly, we can't evaluate the solution correctly. In most almond flour muffins, the issue isn't taste, it's structure. They bake up compact, they don't rise much, the crumb is tight, sometimes crumbly, and sometimes slightly oily. So if toasting works, we should see improvement in rise, volume, air pockets, crumb structure. That's our standard. But here's where it gets interesting. Toasting removes moisture. So the next question becomes, what role does moisture actually play in almond flour baking? I toasted half a cup of almond flour. The raw weight was 53 grams. Toasted weight, 47 grams, and something changed. But visually, it still measured half a cup, which I was very surprised at. That means the structure of the particles shifted, not just the weight. So toasting reduces surface moisture. It slightly darkened the flour, and it can deepen the aroma. But almond flour doesn't contain gluten. It doesn't build elastic structure. So if we reduce moisture, are we improving structure? Or are we removing one of the only things that helps create lift? Because without gluten, lift comes from steam expansion, egg protein structure, fat behavior, and steam requires moisture. So if we reduce moisture before baking, what happens to steam expansion? That's what we're about to find out. Same recipe, same measurements, Same oven, same time. The raw almond flour batter looks slightly thicker. The toasted flour batter looked looser at first, but baked differently. And here's where things shifted. The toasted muffins rose less, noticeably less. The raw almond flour muffins had more lift, more dome, more visible air pockets, which creates a problem for the toasting theory. Because if moisture reduction improves structure, why did rise decrease? And here's another layer. The toasted flour didn't produce a dramatic aroma change, as was alleged on the internet. It wasn't transformative, which means we lost moisture but didn't gain significant flavor. So now the question becomes, if structure didn't improve and flavor didn't dramatically improve, what did toasting actually? Here's the result. The raw almond flour performed better. It rose higher, it retained moisture, it produced a lighter crumb. The toasted version was denser and drier, with no meaningful improvement in flavor. So toasting does change almond flour, but not in a way that improves structure. If you were hoping it will fix density in low-carb baking, it won't. It removes moisture, and moisture is one of the few tools almond flour has to create lift, which means the real limitation isn't preparation, it's the flour itself.